So today, lesson 3.2, I can transform an absolute value graph. That's our focus for today. You guys are sitting in your teams because the first part is an activity. It shouldn't take us the whole hour. It should be pretty quick. So let's look at the first activity. You're going to explore the absolute value function and the transformations on the Desmos graph, and you're going to complete 1 through 7. It's going to guide you through how to use it. So I want 1 Chromebook per pairs of partners, because there's 4 of you guys. So get out a Chromebook. I've got the URL there. Type it in. Let's get started. So we're in the notes section now after 7. So I've got a little table for you. Here's the first translation, right? If I say you need to translate the graph, what I'm talking about is a shift left or right. That's H. Or a shift up or down. That's K. So if you see in a word problem or the instructions for an absolute value equation, if it says translate the graph, it's talking about one of these shifts, up or down, left or right. If in the directions it says reflect or a reflection, that means you're flipping the graph. And that was controlled by which variable? A, right? And really we're looking at when is A positive or negative. That's going to help you flip it. A dilation is also affected by your A, and it might stretch or shrink the graph. You guys saw it getting wider or getting smaller and shrinking. So these are the 3 types of transformations. You should have that filled out in your little table in your guided notes. The graph is to find some points. So let's recall from yesterday. To find the vertex, it's the opposite of the B over the slope, comma the C. What is my slope for just X? Do you know? What's the slope for just X? It's 1. Okay? What's my B? 0. What's my C? 0. So the vertex, as you can see on this graph, is 0, 0. Yesterday, when we were doing the homework tables, I recommended that you start with your vertex in the middle, and then you look at what's happening around it, so you get that nice symmetrical picture. And you can see from our values here, from our graph, that these are the values we get for y equals the absolute value of x. So you should add a table here. You should be graphing it for your notes and parent function. Add a table, please. Okay. Show the work for the vertex. Any other questions? Let's do an example of a vertical translation. A vertical translation. When I do a vertical translation, we're talking about the C value. If I look at this general equation, we're looking at the C value. Again, you could write C or K. All right? It goes up and down. I want you to graph this one. Graph this one in your example. Basically, it's the parent function, but what has happened to it? What's happened to our parent function? Look again. What has happened to our parent function? What happened to it? Look at this graph compared to the graph you have for your parent function.
Yeah, the vertex is higher up.
It has a C. The vertex is higher up. It has been shifted up 2 units. Shifted up 2 units. So go ahead and sketch that out. If I were to make the table, I would just take the table values and add 2 to all of them. That's it. My vertex has moved up. So it has all the rest of the points. You're graphing this for vertical translation. Write down the equation so you know what you're looking at.
Didn't we start on 2?
Sure. If we count from where we started on 2, it went down 3. But if we count from the parent function, it went down 1.
Gotcha.
Hey, great. We got a horizontal translation now. Let's graph this one. X minus 2. Notice, x minus 2. It's a minus 2, but it went in the positive direction. You should write this down. Write this down. Again, you can have B or H. It doesn't matter. B or H. When B is positive, it actually goes left in the negative direction on your graph. When B is negative, it actually goes in the positive direction. Why do you think that is? Say it, Addie. An absolute value function? Or opposites? Okay. Again, we're going to look at the point. 2, 0 is our vertex. You're going to go down 2 and up 2 from your vertex and have those points in your table. So you get a nice symmetrical shape. Any questions on the horizontal translation? Moved it to the left. So when I have addition inside the absolute value, it's going to move it to the left on the graph. So just another example to look at. You don't have to graph this one. Questions?
So, the y,
Okay, next we're going to look at a stretch or a shrink. Thought we were. Oh, we're going to do a combination. What changes are happening to this equation? Turn and talk. This just has translations in it. No stretches, no reflections. Turn and talk right now. Can anyone tell me in words what happens to this graph? Go for it.
It moves to the right 1 and up by 5.
Right 1, up 5. Do we all agree?
Yep.
From our parent graph to this graph, that's how it's been transformed. Great. Let's move on to the next example. Here's the graph of it. It went right 1 and up 5. Cool?
Yep.
Great. Let's do a vertical stretch. Let's graph this one. It's 2 times the absolute value of x. It's thinner. It's making it thinner. You're graphing this one on your paper. You're adding your table in. We can see the vertex is still at 0, 0. That's our vertex. Notice this time we don't go to 1, we're going to 2, and then we're going to 4. Sometimes I think about a stretch as a multiplier of the parent graph. Basically, it took those y values and multiplied it by 2. Turn and talk with your team. What's happening? And then talk about what's happening to the value in the tables.
Over 2.
It's like opening up.
You're doing this, it's like you're doing this.
Yeah. Think of it as two legs. And the bird Yeah. Yeah, what you said.
No. I want to point out, look. Refocus, please. Refocus, please. Notice that I used the same x values that I would have for the parent graph, and now these y values have been cut in half because of this multiplier out front. Questions? Do you see the difference? You see how it's changing our graph? Great. Let's do A reflection. Let's graph this one. You should have a reflection graph. Let's graph this one for the reflection. Write down the equation y equals the negative of the absolute value. So it's flipping it over our x-axis. We can make the table of values. Again, the vertex is 0, 0. But this time, all of our y values are negative. Why are all our y values negative? Because the negative is outside the absolute value. So whatever happens inside the absolute value, we're still going to do the opposite of that. And that's what a reflection does. It flips the graph when there's a negative out front. Write down the equation and graph it. Here's how I would start this. I would find the vertex. Find your vertex. That'll be your middle point. Try it with your team. Ready, set, go. Let's talk about it. To find a vertex, you take the opposite of your b divided by your m, comma c. We should have gotten negative 2 over 1, comma negative 1. So the vertex negative 2, negative 1. Did we get that?
Yep. You got it wrong.
When we look at the table, you're going to go 2 values above or below. So on a number line, I would go more negative. Negative 3, negative 4. I would go on a number line more positive. So negative 1 is greater than negative 2 and 0. And then I'm going to plug this information into my equation for each x value and solve for the y's. I think we need help with solving for the y's. So let's do an example. Let's find our y when x is negative 4. So this is the work you should be showing. If you don't have a table, you should be writing this down. Negative 4 plus 2 is negative 2. When I have an absolute value and a number out front, it implies multiplication. I see some adding. There's no adding symbols. So I'm going to take the absolute value of negative 2 and I get 2. I have to follow my order of operations, so I get negative 6 minus 1, I get negative 7. If you haven't noticed yet, these are symmetrical. So what would 0 be?
0.
Negative 7. They're symmetrical. So now just find what happens when you plug in negative 3. It's symmetrical, so you can find the other value too. Give it a try on your paper. When you're done with your table, go ahead and graph it. Is the vertex in the middle of your graph? Does it make a V? And does it open downwards because that value out front is negative? Check those things. Try this.